I was hoping that I could put a review for your Chapter 10 test online. Your test is online and your review is going to be online. So hopefully this video will help. I've made up a set of problems. I have 20 problems here, and they are similar in nature and difficulty to the ones that you'll be seeing on the test. The first question asks you to find the square root. This problem will contain a perfect square. So the example I'm going to do is to find the square root of 400. You certainly could use your little slip of paper with your squares. You could use your calculator, or perhaps you just know that the square root of 400 is 20. Problem number 2 asks you to find the cube root. This will also be a perfect cube, and you can use your slip of paper or your calculator if you know how to do cube roots on it. There will also be a variable in this problem. So finding the cube root of 27x to the 6th. The cube root of 27 is 3 because 3 cubed is 27. The cube root of x to the 6th, remember that when you're dealing with exponents and variables, that you divide the index into the exponent, and that will give you x to the 2nd power. Numbers 3, 4, and 5 say to use radical notation and to simplify if possible. Number 3, it has 81 to the 1/4 power. Okay, as far as using radical notation, this is the 4th root of 81. If this can be simplified, then the answer choices will be the simplified numbers. The 4th root of 81, you could use a little slip of paper or do the nth root on a calculator, and it turns out that it is 3, because 3 to the 4th power is 81. Number 4, I have negative 64x to the 12th raised to the 1/3 power. That means since all of that's in parentheses, all of it goes under a radical, and the index is 3. I have negative 64x to the 12th. Hopefully you remember that you can take the cube root or any odd root of a negative radicand. The answer will be negative. It turns out it's 4 because sorry, that's one of my dogs barking. That dog weighs about 5 pounds, but he has a very annoying bark. All right, let me see if I can go on. Now I'm going to divide my index into the exponent of the variable. That's going to give me x to the 4th. Okay. Continuing, number 5 is the last one in this group. It has the number 243 raised to the 4/5 power. Now there are 2 ways to do this. What I recommend though is that you take the 5th root of 243 so that you are taking the root of a number. Once you get that answer, raise it to the 4th power. You can raise 243 to the 4th power and then take the 5th root, but the numbers will be huge. Okay, the 5th root of 243. I think you can probably find this on your little chart. And it is 3. And we're going to raise 3 to the 4th power, and that's going to give you 81. So when you have both a numerator and denominator, neither one of them's a 1, you can do them in either order. I like to usually take roots and then raise to powers. So I was able to simplify each one of those. Your test will be multiple choice, and you'll be able to see what kinds of answers are waiting for you. The next two questions ask you to simplify. It does have the little statement. It says assume all variables represent positive real numbers. That's so that you do not have to use any absolute values. No absolute values on this test. And it is the square root of 108 x to the second. Now, if 108 were a perfect square, I would just take the square root of this, and that would be simplifying it. But it is not a perfect square, so I need to factor it. Start thinking about perfect square factors and see if you can think of one that might go into this. And hopefully you will figure out that 36 will go into 108 as you think about perfect squares. 49 will not go into it, but 36 will, and I started from numbers that were smaller than half of that. It's 36, divide 36 into that, and you'll find out it goes 3 times. Perfect square radical, non-perfect square radical. X to the second is a perfect square, so it stays up front. There are no x's in the back. That means that my final answer is the square root of 36 is 6, the square root of x squared is x, times the square root of 3. That's number 6. Number 7 is under the same set, and it has 98 k to the 7th, q to the 8th. All right, once again, that's not a perfect square, but I think maybe I can factor it. The square root of 98 is 49 times 2. K to the 7th. Because that's an odd exponent, it's not a perfect square, but if I take 1 away from it, that will leave me with k to the 6th. Q to the 8th is a perfect square, and that goes in the front. I can take the square root of the first radical, that gives me 7, k to the 3rd, q to the 4th, taking half of those exponents, times the square root of 2k. And that is my simplified answer. Problem number 8, the instructions tell me to add or subtract. Once again, it says assume all variables represent positive real numbers. I'm not going to write that, I've just said it. Problem number 8 has negative 10 times the square root of 75 plus 8 times the square root of 108 plus 5 times the square root of 192. And I'm going to make myself some workspace down here. The first thing I want to do is see if I can simplify negative 10 times the square root of 75. The negative 10 will drag along with every time I write this down. Now 75 is not a perfect square, so I'm going to see if I can factor it. The square root of 75 has as a perfect square factor 25. 25 goes in there 3 times. Negative 10 is still tacked on. The square root of 25 is rational 5, and it's times the square root of 3. Multiply these two for negative 50 times the square root of 3. That goes right back up here. That's negative 50 times the square root of 3. The next part is 8 times the square root of 108. Keep the 8, and let's factor the square root of 108. I think we've already done this. It's 36 times 3, and you'll begin to see repetition of numbers. Keep the 8. The square root of 36 is 6 times the square root of 3. That's 48 times the square root of 3. Finally, I have 5 times the square root of 192. Keep the 5, and 192 is not a perfect square. All right, I'm kind of hopeful that 3 is a factor of that, and sure enough, 3 goes in there 64 times, and that's kind of a sneaky way to get my square root of 64. Don't always count on that though. I have all square roots of 3 here, but that doesn't by any means always happen. But in this problem, it's 5 times 8 times the square root of 3, or 40 times the square root of 3. Back up to my problem. 40 times the square root of 3. Now I need to take negative 50, positive 48, and positive 40, and that's going to give me, if I can do this, how about 38 times the square root of 3? And that is my final answer. This is all the work that it was involved. Don't try to do your test in your head. Be organized and write down your problems. Numbers 9 and 10 ask you to multiply, and once again, after the word multiply, it says, simplify if possible, assume that all variables represent positive real numbers. Number 9. I have parentheses, the square root of 6 plus the square root of, plus rational 3 times the square root of 6 minus rational 3. And I hope that you're sitting there looking at this saying, oh, I know a relationship between those. Those are conjugates. So when I do FOIL, I'm going to multiply the first. Square root of 6 times square root of 6 gives you the square root of 36, which is back to 6. The radicand pops out. Outers and inners, it is not necessary for you to look at these because they will be opposites. So then I just multiply the last. That gives me negative 9. Final answer is negative 3. The product of conjugates is always real. Number 10. I have 8 times the square root of 11 plus 7 quantity squared. Okay, there are two ways you could do this problem. I think most of you will write down 8 times the square root of 11 plus 7, 8 times the square root of 11 plus 7, and you'll write it down twice. And you'll do FOIL. Product of the first. If I multiply 8 square root of 11, 8 square root of 11, that will give me 64 times 11. And I don't have a calculator with me, so I'm going to do that right here in front of you. And that gives me 704. So I'll erase that. And I have the product of the first is 704. Outer product. That's going to be 7 times 8 times the square root of 11. I can multiply these two for 56 times the square root of 11. The inner product is the same. It is another 7 times 8 times the square root of 11, or 56 times the square root of 11. I will be combining these in a minute, and I'll add those two together, so I have 112 times the square root of 11. Product of the last, 7 times 7 is 49. Usually when you multiply things like these, you're going to get some real numbers. You're probably going to get, some rational numbers and some irrational numbers. So if I add my 704 and my 49, and I've already added the two radicals together for 112 square roots of 11. If I add these two together, I get 753 plus 112 square roots of 11. And that's kind of a big, ugly product, but keep in mind that this will be multiple choice and the correct answer will be sitting there waiting for you. Numbers 11 and 12 both ask you to rationalize the denominator. For number 11, I have 3a over the square root of 5. To rationalize a denominator that has a single radical, I'm going to multiply by the radical over itself, and that gives me 3a times the square root of 5 over, hopefully you remember, the square root of 5 times the square root of 5 is 5. Look at your numbers to see if you can do some reducing with the rational parts. You cannot in this problem, so it is complete. Problem number 12 has the square root of 6 over the square root of 7 plus 9. To rationalize this denominator, because it has two terms, I need to use the conjugate. So it's the square root of 7 minus 9. I'm going to use the distributive property. That gives me the square root of 42 minus 9 times the square root of 6 over, I'm going to multiply the denominators, and those are conjugates. Square root of 7 times the square root of 7 gives me 7. The square root of, that's not a square root. 9 times 9 gives me negative 81. 7 minus 81 gives me negative 74. Now, there are many possibilities for the way that answer might be written. I think that it will probably leave the negative in the denominator. Now, don't try to reduce this 74 with this 6 or this 42, because the 74 is a rational number and these are irrational numbers. 42 does not have a perfect square factor, so I think we are done. Go ahead and leave the negative with the denominator. Problem number 13 asks you to solve. This is an equation. I have the square root of 6q minus 5 is equal to 5. The rules for solving an equation with a square root is get the radical isolated. It's already isolated. Now do the inverse, which is to square the left side and square the right side. When I square a square root, I get the radicand to jump out. When I square the right side, I get 25. I need to add 5 to both sides. That gives me 6q is 30. Divide by 6, and q is 5. You would need to check this to see if it's extraneous. That's the square root of 6 times 5 minus 5 is supposed to equal 5. That's the square root of 30 minus 5 is 25. So the square root of 25 is 5. That's equal to 5. It checks. That means that that's my answer. If no solution is the answer, then that'll be one of the answer choices. The next problems have to do with complex numbers. And it says for the next group to write in terms of I. So number 14 is the square root of negative 81. Well, that negative, I could do this a lot of ways. The square root of 81 is a perfect square, and actually the square root of negative 1 is a perfect square. That will give me 9i. And you might could just do that in your head. Anytime you're taking a square root of a negative number, you're going to get imaginaries. Number 15. It asks me to write in terms of I the square root of negative 116. So I'm going to, because there's a negative, and only because there's a negative, I'm going to try 3 radicals, put negative 1 in the middle. Now a perfect square that goes into 116, let's see. Okay, let's see, if I break this into 2 radicals, I think 4 will go in there, and it will go in there 29 times. And you might have tried several perfect squares to see if they would go into 116, but I think it's going to turn out to be 4 and 29. So that gives me 2. The square root of -1 is I times the square root of 29. Number 16. The instructions first. It says to perform the indicated operations. And I'm just going to shorten that. Perform the operations, write the result in the form A plus BI. So every answer needs to be in that complex number form. Number 16, since we're studying complex numbers now, has 9 minus 5i plus 7 plus 3i. When you're adding complex numbers, you add the real parts. And here are my real parts. So I have 16. And add the imaginary parts for -2i, and that's my answer. And it is in A plus BI form. Number 17. I have 3 plus 5i minus -6 plus I. Well, because this is subtraction, I'm going to change to addition, and I'm going to change the sign on that term and the sign on that term. Always do that with subtraction. So I have a +3 and a +6 for 9. I have 5i and -I for 4i. Number 18, I'm still performing an operation. It does sneak in there and tell you to multiply. So I have 8 minus 8i times 4 plus 9i. I need to use FOIL to multiply these. So I have the product of the first, and I'll go ahead and write that out. It's going to be 8 times 4, which is 32. Outer product, the outer product is 8 times 9i, which gives me positive 72i. Inner product is -8i times 4, which is -32i. Product of the last is -8i times 9i, gives me -72i squared. But hopefully we remember that I squared is the same thing as -1. -72 times -1 is positive 72. So now I'm going to add my real parts, and together that will be 104. Then I'm going to add my imaginary parts, and it's actually going to cause me to subtract, and I should have 40i. So once again, your answers to addition, subtraction, multiplication, and when I get to it, division, will all be in the form A plus BI. Number 19 asks me to divide, and the problem is 5 plus 3i over 5 plus 2i. Just like I did with radicals, I'm going to multiply by the conjugate, which is 5 minus 2i, 5 minus 2i, conjugate of the denominator. All right, in the numerator, I'm going to use FOIL. The product of the first, 5 times 5 is 25. The outer product is minus 10i. The inner product is plus 15i. And the product of the last is minus 6i squared. Now, I need to take a moment and simplify that if I can. And I remember that I squared is the same as -1. So this is the same as, and I'm just going to go ahead and write it here, and then I'll get to my denominator in just a minute. This is going to be 25 plus 6, because it's a minus 6 times a minus 1 gives me a plus 6. Then I have negative 10i and positive 15i for plus 5i. That gives me a numerator of 31 plus 5i over the denominator conjugates. 5 times 5 is 25. That gives me negative 4i squared, but we know that I squared is the same thing as negative 1. That turns into plus 4. 25 plus 4 is 29. When you check your answers, it will not look like this. It will look like 31 over 29 plus 5 over 29i. If either or both of those fractions could be reduced, you should do so. All right, sorry. Number 20, this is the last one, and it says, find the power of I. And this particular problem has I to the 18th power. I will take 18 and divide it by 4, because in there 4 times, that's 16 with a remainder of 2. The only thing that really is significant to me in this is the remainder of 2. That means that I to the 18th is the same as I to the 2nd, and hopefully you remember that one. It is equal to negative 1. So I to the 18th is negative 1. All right, gone back up to the beginning of this. I'm going to double check my answers because I don't want to leave you with anything that might be incorrect. So here I go. I'm looking at my answer key right now, which I had not looked at before I started. And everything's looking okay. Whoops. Guess I moved way too fast. Okay, that one's right. Number 11. Yes. Number 12. Yes. 13 is correct. 14, 15, 16, 17, 18, number 19, and number 20. Okay, so I have verified those, and so I hope this is helpful and that you are ready to take your Chapter 10 test on radicals.